Right, so once again we are streaming this live, so please do not swear, please do not ask questions you don't wish to be publicly broadcast. Today we're going to be looking at neuroscience and education. It feels almost nostalgic to have got to this, the last lecture, last formal lecture. You're probably wondering what's going to happen next week and the week after. Well, the plan is for me to look at all of your posters, put those posters into categories, and notify you of which category you are in and which time we will be meeting, either next week or the week after, depending on which group you're in. But I seem to have only left myself 1 week in which to do all this, and I'm slightly intimidated. One of you asked me this morning, can you promise that you're going to get these posters back within a week? And I had to say no, but I am going to try to do that, because otherwise my well-formed structure is going to disintegrate, because you have to know which group you're coming to. But it does mean that you're only going to be coming to part of one of those next 2 sessions. Okay, so obviously those people who are coming from a distance and have family commitments, etc., I know that you need to know as soon as possible which and when you're coming along. So I will do my best to try to organise those as quickly as possible. So the other thing is, you've submitted your poster, of course, haven't you? Yes, good. Any problems with submission? I can't really help you with them. You have to talk to the office because they're in charge of the system. Also, some people are emailing me on the address that I send out the notification of this video on, and I don't pick up those emails because it goes into a personal Gmail account that I have to use because the university won't let me register with Google Plus on my university web email. Okay, so if you ever do need to email me, don't use the email that you receive to tell you this video is coming online. Yeah, just go to the university website and get my contact details and use that one. Otherwise, I won't pick up your email. So today we are going to be talking about neuroscience and education, because you've had 7 lectures on different topics that have been building up in you an understanding of neuroscience, neuroanatomy, neurodevelopmental function, and also we've focused on some specific areas. But for this last lecture, I just wanted to talk more broadly about this idea that neuroscience is relevant to education. For some of you who are doing a pathway in neuroscience and education, you probably know all this stuff already, but maybe not, I don't know. For the rest of you, this is my last chance to try to convince some of you that this is the case, and I'm interested in having a discussion and a debate about it. There are 2 main reasons why I believe we need to have education better informed about neuroscience. One is that we already have a lot of misunderstandings about the brain out there already. So I'm going to be talking to you a little bit about those. And the second thing is that there are some authentic applications. And I've tried during the last 7 weeks to apply some of those. Of course, some of the most serious applications of neuroscience are more to do with developmental disorders. They're more to do with wider, broader pictures about how teenagers develop and young children develop. But there are some immediate applications which we've sort of experienced some of those as the weeks have gone on. So I'm interested to know your views about those as well. You might wish to offer them. So let's, and do remind me that we do need to have a break, because I haven't put it on my slide. So if I go over an hour, you need to put your hand up and say, hang on, where's our break? Okay, so the first thing is that there is a real enthusiasm amongst educators for the brain. This has been going on for some time. We measured it in 2007. We found that 90% of educators thought that the brain was relevant to the design of educational programs. So there's a lot of enthusiasm, and I always think that that is very pertinent. By the way, we've just done a poll of who uses tablets as teachers, but can you put your hand up if you are a teacher? Oh, okay, so we have got quite a few teachers. Okay, just not teachers that use tablets. Okay. I think this is quite justified, because whether you're, I mean, neuroscience is important whether you're going to become an educational psychologist or a teacher, because teachers are the only professionals that actually on a daily basis are responsible for changing the function, the connectivity, and even the structure of an individual's brain, which is incredible. So obviously, I mean, we know all those things because we've been talking about neuroplasticity. We know that learning, and hopefully you're thinking about learning in a more sophisticated way now. We're talking about environmental influence that is individual specific. That changes the way in which the brain functions, and it can even change the way, the different shapes of the different parts of the brain. So that's a very important message. And so naturally, teachers should be enthusiastic about this. They should want to know about neuroscience, because they are responsible to a large extent for the development of brains. But there are a lot of myths out there. I've had to squeeze this, it doesn't squeeze very neatly onto the slide, but you can see that there's an awful lot of strange ideas about the brain, and they're very, very prevalent. So this is a paper that I published in Nature Neuroscience last year. And we measured some common neuromyths. These are all myths. And we measured them all across the world in different parts. And you can see that there's quite a, I mean, this one up here, we mostly only use 10% of our brains. Half the teachers anywhere in the world appear to believe that. But you know that the brain is active all the time. And if a part of the brain is ever not active, it's not functioning, then you have a serious medical condition. Because although you see those pictures where there's a hot spot somewhere, that's just where the activity has risen above a certain statistical threshold set by the experimenter. It doesn't mean the rest of the brain is not active. It just means that that part is more active in this condition than it was in the other condition. Individuals, mind you, the root of this is probably Einstein in a radio interview, apparently. This is what it's blamed on. Individuals learn better in their preferred learning style. And any of you who work in schools, or if you're going to go into schools, you will find that most teachers believe in learning styles. They believe that if you identify the preferred learning style of an individual and teach to that learning style, they are going to learn more effectively. Now, we don't have any convincing educational evidence for that. And there are loads of different learning styles. The psychological evidence doesn't support it either, where they've looked at the effectiveness in terms of learning and memory by delivering information in different modes that are preferred by the learner. And if anything, it is more effective to deliver it in a mode that is not preferred by the learner. That's what the scientific experiments tell us. And what do we know about the brain? Well, we know the brain is massively interconnected. And seeing me speak, even if you had headphones on so you couldn't hear a thing, your auditory cortex would be activating. Because the visual signal of watching somebody's lips move is so closely connected to auditory concepts that the auditory cortex activates when you see somebody's lips move, even though you can't hear them. Or if I showed you a picture of a bell, especially probably if I swung it, your auditory cortex would activate. That's how interconnected the brain is. So this idea that we can say that, oh, your part of the brain, the visual part of your brain is probably functioning better than the auditory, so we're going to deliver information in the visual part of your brain, the visual part of your brain, doesn't make sense. But look how incredibly popular this is, all over the world. Very, very high. And what a waste of time. What a waste of time. Coordination exercises improve left-right brain integration. Now this may be brain gym. Okay, put your hand up if you heard of brain gym. Quite a lot of you. But actually it's also popular in China, where I believe brain gym is not very popular. So there is obviously something that appeals to one's common sense, this idea that moving your hands and doing coordination exercises, you know, where you're patting your brain and doing this sort of thing, that is somehow going to integrate left and right hemisphere. Hemispheric dominance, whether you're left or right brained, that's another type of learning style. And there's no evidence that it helps to define people as left or right brained. And really, the idea doesn't really make much sense. You know, there are some functions that are more left or right lateralized. Language is generally more left lateralized. Although if you're left-handed, there's a 1 in 3 chance it will be on the right side of your brain. But actually, none of that really adds up to the sense of identifying you as a left or a right brain learner. But you see it in the press all the time, and there are lesson plans available on the internet. Hemispheric dominance helps explain individual difference. Sorry, I've just done that one. Children are less attentive after sugary drinks and snacks. Well, I was really surprised last week when I sent you up to the 4th floor and I gave you a Jaffa cake, and then I brought everybody down again. Nobody ever asked me why I was doing that. And I forgot to tell you. It was only when I was going home cycling and I was thinking, they never asked. And I never told them. And I just wonder what other things I could get away with. I'll try some more bizarre activities on this unit next year just to see if anybody actually asked, why are we doing this? But, you know, maybe that's a problem, you know, maybe that's, you know, we've seen this in these experiments where people are taken off the street and somebody is asked to electrocute somebody as part of an experiment. And because they are wearing a white coat, because they are seen to have authority, everybody just accepts that this is an appropriate thing to do. You accepted that it was an appropriate thing for me to do, to give you a Jaffa cake. Just one Jaffa cake. I mean, it could have been a gift, it could have been me being kind, but it wasn't really questioned. Francis, yes.
Not only accepted to go, but accepted to climb the stairs.
I know, it was effortful.
There's an elevator, why didn't you just use?
Well, I told them not to, actually.
Yeah,
but nobody did.
Like,
did they?
I was behind you.
Nobody did use it. Right, okay. So, you know, it's interesting that maybe, you know, if you have somebody who appears to have authority, you know, they can tell education to do these silly things, and everyone thinks that it's true. I mean, brain gym is... I have to switch the microphone off at this stage. So a lot of people think that if children have been out in break time, they've been having these sugary drinks and snacks, they're going to be paying attention less. But actually, the research shows that they are paying attention a little bit more if they have sugary drinks and snacks. Yeah. Why don't we have sugary drinks and snacks? Because they rot your teeth. That's the important thing. Okay. But actually, they can actually improve your attention. And drinking less than 6 to 8 glasses of water a day can cause your brain to shrink. Well, it's just not true. It's a very popular idea in this country because of the advertising of drinks manufacturers. Now, the one you can't see, and it's a shame actually, because I think I'm going to have to take this. I want you to see it, so I'm going to have to change it. But the one at the bottom, I think, is probably the most insidious of all of these myths. I think it's really important for teachers to know a little bit about brain development and how genetics and the environment interact together to produce development. And this is one of the reasons why, because a lot of teachers actually believe that if a learning problem is associated with a brain difference, there's nothing you can do about it. Biology means biological determinism. And we have actually measured this in a group of trainee teachers in this country, that the more that group of trainee teachers believed in genetic determination, and some of them believed very strongly that genetics was the prime factor for children's educational outcome, and the more they believed that, the less they felt there was anything they could do for children in the classroom, the less agency they felt, the less empowered they felt. That seems to indicate that actually it's important for teachers to know something about brain development, because if they get this idea in their head that it's all genetics, they don't think there's anything more they can do. So why should they bother to try to do it? So there are some important messages that need to be got across to educators. A lot of these ideas do revolve around what is good and what is bad for brains. It's a very simple question. And these are all things that have been brought into the discussion. You may recognize some of them. Video games, are they good for brains? Are they bad for brains? Fishes, are fishes good? Fishes bad? Drink more water is a very easy thing to do. You'll find that a lot of these ideas, I can see somebody drinking water at the back there, you see now. Are you doing it because you're thirsty?
I saw the water.
Yeah, they are. That's what happens, isn't it? It's infectious. You know, in a book about brain gym, they ask you to sing, let's drink water, I love water, it gives me energy. I know, it's terrible singing, but it doesn't. It's one of the few things you can consume that doesn't give you energy. So and yet we have all these articles on the BBC telling you that it does, and it can help your academic results. There's always a seed of truth in these things. 80% of your brain is water. Mild dehydration can stop you thinking and stop you learning. Drinking too little water can result in injury or death. But, you know, and people do feel more attentive after a drink of water. And you do hear this figure bandied around, 6 to 8 glasses of water a day. It's quite a popular idea. It's been going on around for decades, actually, that idea that we need 6 to 8 glasses of water. But feeling more attentive is not the same as actually being more attentive. And it's been shown that when you drink water when you're not thirsty, you can feel more attentive, but actually it reduces your cognitive function if you drink water when you're not thirsty. And drinking too much water can also cause serious illness and death. So now you're on a tightrope and you're thinking, what can I do? You know, should I drink more? Should I drink less? They're passing it around now desperately. But, you know, really you should drink when you're thirsty, because you have, and I'm trying to remind you now about what you've learned during this unit. You know about the thalamus and the hypothalamus. Well, these work together to produce a balance in your body, to maintain homeostasis. So if you haven't got enough water, your brain will send out a message that you experience as thirst. And that's how you know you need more water. Now, the only time that breaks down is when there are conditions of unusual heat or exercise, when you've been exercising. Now, school sports days are when both of those two things can come together. But the only place where they've ever found voluntary dehydration, where children have become dehydrated even though they have access to water, is in the Red Sea, in the Dead Sea, which is the lowest point on the Earth's surface and incredibly hot. Your brain is unlikely to shrink if you drink less than 6 to 8 glasses of water a day. There is one study showing dehydration due to exercise can increase the ventricles, which kind of means that the cortex must be shrinking a little bit, but it's not related to any change in cognitive function. So there's no sense in which this is necessarily a bad thing. The only serious brain shrinkage that I've been able to find is a man in Japan who tried to commit suicide by drinking too much soy sauce, overdosing on soy sauce. And you know, he almost died, and they had to rehydrate him very slowly, which gave plenty of time for him to have brain scans. And they found that after 3 months, his brain did in fact return almost to its original size. Now, these people are doing brain gym. You might remember brain gym, you might have seen brain gym, really quite strange exercises. You're supposed to have brain buttons here, and if you rub them, are supposed to help integrate left and right hemisphere. But it's a bit like rubbing the radiator in order to mend your central heating. It's going to be as effective. There have been a lot of attacks on brain gym from scientists. There is a website called Sense About Science, which is not on here. I probably should have put it on, Sense About Science, where they have a lot of really helpful information about brain gym, but also other strange ideas that are quite popular. It was exposed on Newsnight as idiotic. Jeremy Paxman called it idiotic. I was on that program. They also had Colin Blakemore, who was then head of the MRC. Actually, it was him that came up with the gag about the central heating. Doesn't seem to have stopped it still from becoming very popular. Omega-3 fish oils. Elliot is supposed to be cured of his laziness because he's been eating supplements of fish oils. Is this true? Well, I put this in small print because I don't really want you to read it, but I'm just saying that if you're interested, you can go to the slide. But basically, there's a lot of circumstantial evidence that supports the idea that omega-3 is important for our brains. For example, mums-to-be who eat more fish, provided they don't get mercury poisoning, are likely to produce children with higher IQs. Okay, that is a fact. So we've observed this in Inuit, for example, Inuit communities where they usually eat a lot of fish, the Western diet comes in, they reduce fish intake, the IQ of their children starts becoming reduced. We know omega-3 deficiency is associated with, can be associated with many types of cognitive dysfunction in development. There have been about 7 or 8 studies of omega-3 is fish oils, by the way, of omega-3 supplements or fish oil supplements with children who have developmental disorders, dyscalculia, ADHD. Half of them have shown an effect, half of them have not shown an effect. Well, that's interesting, actually, you know, and worth pursuing. But in studies, and there have been 2 major studies in large healthy populations, they haven't found any effects of taking these supplements, I'm sorry to say. But there are some interesting statistics that show that children whose parents give them supplements do better at school, whatever the supplement. It doesn't make any difference. It could be a sweet. Just tell them it's good for them and it'll make them clever. So. Learning styles we've already touched upon. The most popular is visual, auditory and kinesthetic. 82% of our teachers believed when we first did this with trainee teachers, but you can see that other statistics show that the prevalence worldwide is even greater than that. There's no evidence for educational benefit, no basis in neuroscience, and the scientists who have conducted controlled experiments say that this is wasted effort. And sometimes there's more benefit from providing a student with their non-preferred learning style. But there is benefit in all students receiving information in all modes, and that is important. Multimodal teaching can be very effective. It just doesn't make sense to label children in one way or another. Caffeine, it's the only psychoactive drug legally available to children, and they use it a lot. Children and adults commonly suffer from caffeine withdrawal. I'm afraid if you're a caffeine user, your ability to think only rises to baseline normality when you've had your fix. The rest of the time, you are below cognitive function compared with people who do not drink caffeine regularly. I know, so I am also a caffeine drinker. I am ashamed, but there you go. Now, what it means to be a caffeine drinker is having 2 or 3 cups of coffee a day, or in my case, about 15 mugs of Earl Grey tea. But you only need 1 of those to be a caffeine user a day, and that is sufficient to, according to the science, to predict those effects. Again, I'm worried about the camera. Gonna have a litigation. So what we find with all of these is that there is always some sort of seed of fact underneath all these neuromyths. There's something that you don't want to throw out with the bathwater. We talk about, so for international students who haven't heard this phrase before, we say you mustn't throw out the baby with the bathwater, which means when you're throwing away something which appears like a load of rubbish, there might be something very valuable in there. And actually it's true with all of these neuromyths that there is some connected fact which is worth knowing. It's true that learners benefit from receiving information in all modalities. It's true that language is generally left lateralized. It's true that dehydration can reduce cognitive functioning. Aerobic exercise is good for the brain. Did you wonder why you went up those 4 flights of stairs? The younger brain is more plastic. But it doesn't mean that you should have learning styles, categorizing people as left or right brained, worrying about 6 to 8 glasses of water a day, rehearsing coordination exercises, or thinking that the architecture of the human brain is fixed at 3 years old. None of those things are true. And what we seem to have here is these little seeds of fact giving rise to these myths, this great big weed here, because of the gap between neuroscience and education. There's a cultural gap. We use different words, different terms, different concepts. We have different professional aims. And what you get in the end is actually created by a lot of biases, including anxiety, because we worry about our brains, but also wishful thinking, because we think about what we love an easy fix. We can find an easy fix. I mean, drinking water to make yourself clever, that's fantastic. It's actually quite cheap too, you know. But neuroscience has an allure, and you can see this in the study of Weisberg. When you present good and bad explanations to experts, they rate them as good and they rate them as bad. Positive is good, negative is bad. When you put in irrelevant neuroscience, like a picture of a brain, or you mention the prefrontal cortex in a way that is not connected at all to the explanation, the scientists actually decide they don't like it anymore, and the positive explanation goes negative. So they're not fooled, and actually they don't like irrelevant information. But the public, it's a different matter. If you're not a specialist in neuroscience, you can still tell the difference between a good and a bad psychological explanation. But when you put in irrelevant neuroscience, the bad explanation starts becoming good. In other words, adding a bit of irrelevant neuroscience, you can sell bad stuff. So you need to watch out and make sure you're not buying it. So if somebody says it's based on neuroscience, don't say, wow, it must be true. You need to say, who says that? Are they neuroscientists? And where is it published? Those are the 2 questions that you have to ask. Okay, I want to start talking next about some authentic applications of neuroscience and education. We'll start these, but then I think we need to have a little break. I'm just looking at the old time here. We've got to 5 o'clock, so I'll do a little bit more. Yes, sir?
Before we move on, can I just say the nuts, seeds and oils are also a very good source of omega-3?
Yes, and I should say, yes, so you're saying that nuts, seeds and oils are also very good for omega-3. As a vegetarian myself, I worry a little bit that I don't get enough omega-3. My partner doesn't eat fish, so her omega-3 must be through the floor. And omega-3 is good for you in all sorts of other ways. You see, you get back to this, that's another seed of fact, that it's good for your joints, isn't it? And there's some evidence, but this is argued about, that it's good for your heart as well. So yeah, I have taken omega-3 supplements myself. And I try to drink I try to eat a lot of fish and eat a lot of nuts. But it's funny how these things get distorted. We also asked teachers in interviews about what they'd heard about the brain, and one of them said, walnuts. Pardon? Walnuts, really good for the brain. Why is that? Well, because they look like a brain, don't they? I have to say, this is actually a teacher who'd done this course as well, which is slightly worrying. But having said that, you see, that's also interesting. I'm going to say, you're going to tell me this, you probably know this, but actually a walnut is one of the highest omega-3 nuts that you can get. Well, that's a bit freaky, isn't it? Is that a coincidence? I don't know. Okay. So mathematics. Things we have learnt that may be useful to education. Well, you know now, see, partly this is a revision lecture, but you know now that there are, in fact, at least 2 broad categories of how we think about number. One of them is in the ancient way that we share with animals. I think it's only animals, other mammals at least anyway. And those are highlighted here in the yellow. And you can see intraparietal sulcus. When we've got loads of things over there and loads of things over there, we have to make a snap judgment. This tree's got lots of apples, this tree's got lots of apples. I've got to make a decision about which tree I'm going to forage for fruit in. And my survival may depend on getting the tree with the most apples. So it's little wonder that we have some basic way of approximating that we share with other animals. We also saw it with the lionesses, listening to the roars of the pride that was surrounding them, counting up sort of estimating the number that were in their own pride and making a decision whether to attack or not based on a ratio. But when it comes to exact calculation, we can see some left hemisphere regions activating in the blue, because we need to talk it through with ourselves. Carry one, oh, that doesn't go, whatever. We actually talk maths through a little. We have those processes, and we know that those need to become a little bit automatic in order for us to learn new processes as well, by rehearsal and by training. But this idea that in fact the formal mathematics may be bootstrapped by this ancient mathematics has given rise to ideas about interventions in school, including ones that emphasize the physical nature of quantity, such as landing the spacecraft on the number line, which is the study that was done by Kustian that showed some helpful improvements. We've also gained an idea that fingers and numbers may be more connected than we originally thought. And that's important because another intervention has shown that making children more aware of their fingers appears to improve some of these initial measures of number awareness that we think bootstrap formal maths. We've also found that mental rotation, and that means the ability to see that these two are in fact the same shape. Yes. So it's typical task. They show you different ones of these, and then they say, is this the same or not? And you have to sort of turn it round in your mind. And if you can do that, that's quite strongly predictive of your mathematical ability. And they've also shown in engineering students that they can improve mental rotation and thereby improve your academic achievement in engineering, which shows that rehearsing mental rotation can improve your science and mathematics ability, and possibly that the differences in mental rotation that we regard as potentially genetic, because males appear to be better at mentally rotating than females, actually could be cultural, simply because it appears to depend on practice. So if you're living in a culture where you're encouraged to do more mental rotation, you're going to have better mental rotation and probably better maths and science skills as well. So that's raised some interesting questions. And anxiety, you may remember that I tried to relax you with a bit of Samuel Barber. Do you remember that for your examination? Because we felt it was probably quite important for you to not have your working memory interfered with. And we also talked about our anxieties, because apparently sharing your anxieties before a test can improve your performance. So we talked about that. And we talked about, I've just been mentioning the number line as well. Reading, now you remember this from your reading lecture, I hope, that there are different ways of coding language. We can code it orthographically in terms of writing, so visual word form areas are important up here, but also we can code it phonologically in the circular regions where phonological coding appears important in terms of the sound chunks, if you like, not sound chunks, but the way in which the different sounds are actually partitioned. And then we can also code it semantically as well in terms of the meaning of the words. And all of those things work together to allow us to use language and communication. And now we're thinking more, rather than a serial box and arrows approach, the brain research is encouraging us to think about these processes working in parallel and in a more complex fashion. And that has given rise to interventions that focus not just on phonological orthographic mapping, but actually all the different ways of coding speech in terms of orthography, phonics, but semantics also. And these multiple component processes, if we can maybe we can use the neuroscience and the measures to identify how different individuals require different versions of those interventions, and we can tailor interventions more accurately by identifying individual problems. We can also use the neuroimaging to test out interventions such as graphogain here and identify the parts of the brain where function appears to change and where changes in function appear to predict the success of the intervention. If that's the case, as it was in this study by Brem, then we have the potential to use neural markers in the design of educational software for reading. Now, exercise, it's about being fit, but it's about using exercise as well. We can see that people who are more fit use their anterior cingulate in a better way. Actually, they need it less, they activate it less because the blood flow is probably more efficiently used. So because that part of the brain is being used more efficiently, it doesn't have to activate so much in a fit person. But also, even short bouts of exercise can improve memory. I have to say, though, this study actually was done with very fit people. I didn't mention that. It doesn't say it there, I don't think. But we're talking about the effects of 2-3 minute sprints, but the participants were athletes. But we don't know whether it would not have worked with somebody, you know, who was not fit. We don't know. Teenage lifestyle, so many factors here are of interest to education because it is a common problem that teenagers turn up at school a bit sleepless, and lack of sleep predicts poor academic achievement. And some of the factors that contribute to poor sleep are technology, but also caffeine, sometimes working together. But also there is a biological change because at adolescence, the circadian rhythms alter such that you are responding to light in a different way. And the result of that is that you naturally want to go to bed later and you have more difficulty getting up in the morning. So there is a biological cause, but there is also strong interaction from social forces because you're now independent. You have friends who are going to bed later. You have a mobile under your duvet. And all of that interacts together. Plus, you probably have a Red Bull on the side of that, you know, and maybe your mobile's got a video game on it, which makes it even more disruptive to your slow wave sleep that you need in order to consolidate your memory of what you've learned, but also it's going to disrupt your sleep for the next day as well. And have I shared this one with you? I'm not sure I have. This is a fascinating study. I show these slides so much that I have difficulty remembering which ones I've shown to who, but I don't think you've seen this one, and I think you should. So 13 to 14-year-olds between 6 and 7 o'clock in the evening, they all experience different types of event. For some of them, they had no technology. Some of them watched TV. Some of them were watching video games, playing video games. And this is a good night in our house because if we could constrain video game play to between 6 and 7 o'clock, we would be very happy. But nevertheless, we still see a disruption in slow wave sleep. They get most slow wave sleep for the basal conditions in which there is no technology, less slow wave sleep for TV, and the least slow wave sleep for playing video games. And remember, this is like it's about 3 hours later, isn't it? They probably go to bed. Well, it's quite surprising. And together with that, you can see correlated with those changes, they did some homework immediately after that event. And they tested them on the memory for that homework. And you can see that they forgot least for the basal conditions, forgot more if they'd been watching TV before their homework, and forgot most if they'd been playing video games before their homework. So you can see there's a correlation between sleep loss and a failure to remember your homework, what you've tried to revise. And this is between 6 and 7 in the evening. And it would be really fascinating to see what would have happened if they'd done those activities between 8 and 9, for example. Yes?
Some of the reviruses of smartphones were even more disruptive. They compared with video games
Yes, and I'm not sure if I've got that here, so let me say why. Because they think that the bright screen held close to the face is more disruptive of melatonin secretion. Yes, that's right, because it really makes a difference what you do on it. So if you're interacting with it, whereas if you've got a Kindle and you're just, all these commercial names come out, are going to be litigated to the end of the world, I think. But if you have a Kindle, then it's not bright screen, you're just reading. And my guess is that that wouldn't disrupt your sleep very much at all. It might even help you go to sleep, I don't know. Somebody else had their hand up.
What were they doing in the other case?
Well, in the basal conditions, they were doing nothing, but we don't know what they were doing. We assume they were not revising for their test. But we have no idea. But I think this is one of the problems with all these studies, is that they say playing computer games, and you think, well, what computer game? Was it a shooter game, or was it a strategy game, or was it something quite social? And we know that makes a difference, but they often don't report that. Well, there's been a lot of fuss about the effects of technology on the brain. We've got Manfred Spitzer writing a book called Digital Dementia. He's particularly worried about tablets, actually, people who are doing that tablet research. He thinks that swiping the screen is disrupting children's holistic development, or development of holistic awareness of the world, because they think that everything changes when you swipe, and actually very few things change when you swipe. I'm not really sure about this theory, I've got to admit. But we also have other people in our country, other very well-known scientists, such as Susan Greenfield, who's very unhappy about children and technology. And I get asked sometimes to sort of argue with her about things. So I try to sort of, I'm the poo-pooer. I say, oh, it's not really a big deal, really. And Susan's sort of very, it's terribly bad news. It's really bad. I mean, I think there are reasons why we should be concerned in some areas. We need more research. I think parents need to know what we do know, but I don't think we want to get hysterical. But it's very much something that's being discussed. And technology does change your brain. This is a fascinating study. The parts that are illustrated here, the size of them can be predicted by the number of friends you have on Facebook. Right? So if you've got more friends on Facebook, you'll have bigger parts of entorhinal cortex and other bits, which are related to your social memory. But it's what you'd expect, because we know the brain is plastic. So if you keep doing the same, if you're practicing something a lot, a particular type of function, then the brain region that is most involved in that function will change its structure and probably grow in size. We know that the brain is plastic, and we can see that in a range of different ways, but the study I like the most is the one with Margaret Delays, where she looks at adults learning complex multiplication, because there you see adults' brain functions shifting from frontal regions, which are very much to do with working memory, to more posterior regions, which are more to do with automaticity. And that's something that I think we came across earlier. Did we ever look at this before? I think we have, yeah. And so technology is rewiring our brains. And this study here shows how naive users who've never seen Google before, when you put Google in front of them, compared with reading a book, they have an increase in visual cortex. Whereas if people have already been using Google quite a lot, look at all those additional regions of the brain that are activated as a result of being a regular Google user. So you could say, oh my God, this person's brain is on fire. Google has completely changed their brain. But actually, if you've learned how to use Google, you would be planning, you would be using strategies, you would be using search, approaches to searches and decision making, and these are all represented in these different regions. Language regions are activating as well, probably, as you're thinking about different word associations. So that's exactly what you'd expect to see. That's not necessarily a bad thing. But interestingly, technology is changing our brains in other ways. which are more interesting, and perhaps we have to worry about more as educators. So in this study by Betsy Sparrow, her team asked easy questions and difficult questions, and before people answered, they flashed up little cues which were there to disrupt and basically prime the brain. So if any of these cues are involved in the processes of answering, you would expect there to be a delay in the decision, essentially. That's the way it works. And when words flashed up that were to do with computers, such as Yahoo and Google, people were no slower in answering the easy questions, but they did become slower when answering the difficult questions. In other words, Google and Yahoo activated parts of their brain that they've had difficulty in suppressing, and as a result interfered with them answering the difficult question. And so that really shows that when we have difficult academic challenges, we are primed now to think about computers in a way that we would not have been before. And I often find that people are asking me questions, and I've looked around and looking for my mobile to search something even before I've known it. I mean, literally, it is automatic. I'm thinking, why am I picking this up? Oh, yeah, someone's just asked me a question. It's quite weird. And they also, you know, we are getting better. One of her other findings was that we are getting better at remembering where information is, but getting worse at actually remembering that information. Because we're now having to deal with so much more information, that the way in which we are remembering, the way we are using our memory has changed as a result. So those are things that we probably do need to think about. I'm going to just have a little break there, I think. Those people who have kindly identified themselves as teachers who use tablets, I know that these researchers would so much appreciate you filling in a very small questionnaire, but it's not compulsory. Ethically, it cannot be. You are free to withdraw at any time. So let's have a 5-minute break, loo break, and then we'll carry on. Hello.
We're talking about that motor skill, the rotation. The rotation. Do you know
yes. If you go to the MBESC website, it's one of the, you know, this is your research centre. You know this website?
I didn't have.
Well, yeah, I hope everybody knows that. It worries me, that does.
I mean, I was in the first launch when you had it.
Okay. Well, if you go there now, there's the MSc in Neuroscience and Education pathway, and on there, I think you'll find that there is course content. Hang on. Oh, MSc Neuro Ed Reading. You can download it from there. It mentions it on there, I think. Yeah, I think it's on there. Yeah, so are you part-time or full-time? Oh, okay, but you couldn't make the workshop today.
No, I have to interview Liz for my IEI research.
Ah, you told me that, didn't you?
Sorry.
Yeah, no, it's a shame because it was about dissertation and you need to start thinking
about that.
Yeah, well, that's what we were doing in that tutorial, you see. Yeah, I know. I think it'd been better off going to the tutorial, really.
It's
Really.
just that Liz is going to the US, and I wouldn't have been able to conduct the interview with her.
Okay.
I'm going work tomorrow, and we were going to analyze the interview.
Yes, I know. Well, don't worry. But we do have individual tutorials coming. Well, not individual, but there's 4 of you at a time. So that's what's happening in the next couple of weeks. Yeah, you but can you start trying to identify a dissertation question that you want to work on?
A few. I mean, can I speak? Can I interview you now?
Well, no, because that's why we have the tutorials. Sorry, that's the only way I can manage it, really. That's why I get people together to talk about them. But the important thing is to bring it along to that tutorial. We'll have there's only be 4 of us there, and so we'll each have 15-20 minutes to talk about it, and then with each other and run through it. Is that all right? Yeah, write them down. We've got plenty of time to think about it. It's really early. We don't normally start talking about it until February, March, but this year we're trying to get students to start thinking about it more. I don't know, has this happened in psychology at all? Have you started?
Yeah, well, the part-time, so I'm...
Oh, part-timers, so okay. Yeah. Oh, okay. I think everybody this year is being encouraged to think about it a bit earlier. Unless you're not doing your dissertation, of course, then you don't have to worry about it. Yeah, I'm really, really pushed at the moment in terms of time.
10-minute interview max. It says that it takes about an hour minutes to get the attention.
Yeah, I mean, you could. Let's see if I can get through this, because I'm thinking I might finish a little early today because it's the last one, and maybe there'll be time. Would you be able to do it after? Yeah, just get that done. That would be helpful. Hello.
Hello. I just remembered that you need volunteers.
Brain stuff. Yeah, it's a sort. Yeah, okay. We're not looking. I mean, yeah.
I just wanted to.
I know. I really want to organise it. I hope that we'll be running one in the summer. I hope. But we're not at the moment, but I hope that we will.
I feel like that.
Yeah, are you right-handed?
Yes.
Have you got any metal in your body? Any metal in your body? Sounds good. You might be good then. Yes, hello.
I was just doing my poster today, and it was inevitable to discuss the
theory of mind,
and therefore information processing theory, as well as the cognitive ability. And I felt this becomes so close to the as a mind, obviously different wordings, but you can see because I was discussing the connectivity of the brain in autism.
Yeah.
So, obviously my essay is going to be very different, but
I'm not sure that the posters are actually checked by the plagiarism software. I'm not sure if they can be, because I would have thought it'd be a different format.
Yeah.
I wouldn't worry about it.
Yeah,
too much
I
anyway.
worry about it because you can see by looking at all the qualities in the
I
breeding
wouldn't.
connectivity and autism, it has to be these three.
Yes, I wouldn't worry about it too much. I think it's the essay you have to chiefly worry about.
Yeah, no, that, I won't even look at what you have in mind. I think it's
No, you can do, but just never cut and paste is the real.
And also, obviously, with the essay, I guess you have to talk about the language, the reading, all the different parts of the brain. You have to make sure you understand everything you've done on the different sessions.
Yes,
So you have
yes,
to combine
that's
all
true.
together in what you're covering, right?
Yes.
Right, so yeah.
Well, I mean, I think you don't have to combine everything that you've covered in this unit.
Yeah.
You just really are using that to.
I mean, your knowledge of neuroscience.
Yeah, you've demonstrated generally what you're doing in the test, and really what you need to do now is demonstrate that you can get involved with just your specialist area.
Yeah,
You know.
using the different parts of the stem.
Yeah.
Thank you.
Okay. Right. I want to get you back. Oh, hello. Are we back? Hello. Oh. Brilliant. I want to zip through this a bit more now, because I want to talk a little bit about the assignment before we go. Genetics is another area where we are finding some interesting things out. I don't think it's ever going to be possible to, well, not in our lifetimes, I wouldn't have thought, for it to be useful to diagnose, to be able to identify genes associated with cognitive function and translate those into educational programs. I find it quite difficult to believe we're going to be able to tailor educational programs based on that level of genetic information. Maybe I'm too skeptical, I don't know. But I do think that already we are identifying some specific genes that are potentially helpful to know about. And one of them is the DRD7 repeat gene. Get this back on the full size. Because this appears to identify whether you are a dandelion or whether you are an orchid. I had to see which flower it was then. I thought it might be a lily. No, it was an orchid. An orchid or a dandelion. And if you are carrying this gene, then you are going to be more sensitive to the environment generally. So if you have a bad teacher, it's going to affect you badly. If you have a good teacher, it's going to affect you a lot. Whereas the dandelions who don't carry this gene appear to be less educationally sensitive, if you like. So whatever environment they're in, they tend to sort of trundle along and do not too bad. But the orchids, their educational environment makes much more difference. Now that sort of thing could be really helpful to know that, not just in terms of how you might teach in the classroom, but if you do an educational intervention, we would like to know why it appears to work with some children and not with others. So taking genetic samples can form part of that. Also, of course, in terms of neuroimaging, some of the interference or some of the variance in the images is going to be explained at the level of individual differences. And if we can identify those genetically, as we are now beginning to do, then that can be helpful too. So more and more, when you go for a fMRI scan and we're trying to find out how you respond to a particular mathematical task, then you may be asked for blood samples or saliva samples because we want to identify specific genes that appear to influence your response in that task. So there's now, we're looking towards a combination now of genetics and neuroscience, and that's quite helpful. And there, of course, there are a lot of arguments going on about the role of genes in education. And on the left here, I've put a diagram from one of Plomin's papers. And Plomin has sort of emphasized the extent to which genetic information explains individual variants, so the differences between individuals in terms of their educational outcome. And that's an important thing to bear in mind, but an appropriate understanding of how genes and the environment interact, and a sense that biology is not destiny, is also very important for a teacher to be effective. And I think this correlation between belief in genetic outcome or genetic determinants of outcome and a belief in your own sense of agency and able to help a child really speaks to the need for teachers to have a more sophisticated understanding of genetics. Yes? What? Yeah. I think it will be in that Nature Neuroscience paper. So if you just Google myths and messages and my name, it should come up. Myths, I can't even say it, I wrote it, I can't say myths and messages. An awkward affricate, or fricative, is it? Africa. Okay, so embodied cognition is another area that we spoke about, because you experience some of that. I was talking about, well, why am I moving my hands around? Why are we doing sort of particular types of exercises? It's beginning to help us understand how we transmit unconsciously information. And given the emphasis on face-to-face contact between the teacher and the student, this is particularly interesting, because try as we might to move towards virtual learning, you're all still sat here looking at me. Why is that? Well, it could be because we don't allow video, we don't allow virtual presence as an attendance, as attendance at the moment, maybe. But I also think that people do generally prefer to have face-to-face contact. That's how they learn. And I sort of have got to feel that I know many of you, most of you, from being in this room with you. And I sort of feel that I communicate better because I make eye contact and I can see that you're really there. And I'm not sure that would have happened if I'd had 100 people online. Spacing and interleaving effects. We experienced some spacing effects. I didn't mention the interleaving effects, but actually how you mix and match different learning experiences appears to have quite significant effects on learning outcomes. So one example of this is if you ask people to look at worked examples and then to do an example themselves, that appears to be more effective than just getting them to carry out worked examples. If you interleave it with other types of activity, we don't really understand why this is, but I do think that neuroimaging is going to help us understand that better. And the spacing effect, we are beginning to understand more about it in terms of this unconscious rehearsal of ideas, some evidence of which we can see through the use of neuroimaging. Reward response, my favorite area. Reward does not predict learning, but the brain's response to reward does. And therefore, we need to understand the brain's response to reward in order to use reward effectively in the classroom. And we've spoken about that, and you've experienced some of the games. And a whole range of other areas, ADHD, developmental disorders, how learners visualize, for example. If I ask you to imagine something, almost as much increase in visual cortex activity will occur as if you were actually experiencing it yourself. So visualization and imagination is a fantastically powerful tool, potentially, for learning. Working memory training, potentially, working memory training appears to improve. I say potentially, why am I using the word potentially? There's an argument. I mean, we have what appears to be very clear data that suggests working memory training improves fluid intelligence. If that's true, then we can actually unlock the gates of plasticity and improve the rate at which children learn through working memory training. And all these changes that occur in adolescence in terms of sleep, risk-taking, executive function, will have an effect on the way in which adolescents are observed in the classroom, the way in which we behave towards them, and perhaps in terms of interventions as well. And more sophisticated issues, which you will come across if you're doing issues in neuroscience and education, such as when should we invest in education? Should we invest in little children or bigger children? Now, there's a whole series of things that we did during these lectures, and I just wanted to remind you about some of them. We passed around a plastic brain because vision and touch comes together early on in the brain and helps reinforce a message, a complex message such as shape. We played Simon Says because the idea of embodied cognition tells us that when you enact something, you're more likely to understand it and you're more likely to remember it. I asked you to imagine a cup of soup because we know that visualizing something can activate almost as much visual cortex as if you were actually experiencing it yourself. That's why I encouraged you to visualize picking up a cup of soup to understand how complex the activity in the brain is related to that very simple task. I tried, I think I probably failed in some parts, to reduce the text on PowerPoint because I know that the brain utilizes similar structures for reading as it does for listening, and therefore it doesn't make sense for me to have a lot of text on the board whilst I'm speaking to you at the same time. You can't process that. I tested you on last week's work because I know that testing increases the attention you're paying to material, and actually there is a massive step difference in terms of how much you remember if you're tested on something. It helps you rehearse, helps you encode, it helps you consolidate memory. And we can, and I did tell you to get good sleep as well, because you know the sleep afterwards is very important for your hippocampus to replay and help you consolidate those memories. I got you explaining to each other because self-initiated joint attention is rewarding. It activates your reward centers, and I hope that you enjoyed explaining those things to each other. It should have improved your memory because we know that that midbrain dopamine increases synaptic plasticity. And we used games. We used a game based on uncertain reward with peer presence because we know that also enhances that reward response. And I got you competing against each other because I knew that you were also getting rewards out of seeing your competitors fail, which you did because I heard you all cheer. I tried to get you relaxed because I know that otherwise those anxieties are going to be taking up valuable working memory storage space. And that's a bad thing. It's okay if you're revising to have a little bit of anxiety, but it's no good during the test itself because this is not about learning, it's actually about recalling. And that requires working memory to pace through those issues. I spaced the learning, so you'll be unconsciously rehearsing during those periods, although it's not straightforward, is it? Because what can I do in those spaces? And I don't know about you, but did you get slightly annoyed afterwards? Like, oh, another break, I just want to get on with it and go home. I don't know. I'm interested to sort of know, actually, how you felt about that. Was it just a bit annoying having a break every 20, 25 minutes? Yes, I found it a bit annoying. So I think it's quite interesting because it's all very well knowing about these things, but it's another issue as to how to implement them into effective teaching. You can't just do it. You actually need to combine it with common sense understandings of how and experience of how lessons work. And I still struggle with spaced learning because I don't really know how to do that. It's a good topic there for a dissertation, I think. You know. Okay, so and we also, which I think is really important, started visualizing neural networks activating each other and giving some sort of basis for the Vygotskian principles of learning, understanding what you know already and building on top of it so that the new learning activates the old concepts and are built upon them. And when you come across those old concepts, they will activate the new ones so that you can bring that new learning in to your revised concept of the world. And talking about concepts, I sometimes worked with concrete ones and then moved on to abstract ones. There was that principle of concreteness fading because concrete concepts are very accessible, but actually abstract ones are more transferable. So start with the concrete, move on to the abstract. And I did give you feedback, sometimes negative, about your mistakes, because I know that at your age, you're very interested in negative feedback, not like these 8 to 9 year olds where we hardly see any additional activation when we start talking about their errors. And we had, you know, nobody ever asked me, but yes, we did have a walk during the last lecture, because I know that exercise is good for improving your executive function. And when you got to the top, I gave you a little sugary snack to give you a little bit of extra energy and boost your attention. I don't know if it helped or not. And why do I always emphasize plasticity? All through this unit, I have kept trying to drill into you that brain function is not determined. It is changed by the environment. The brain is plastic. And this is a really important thing for educators to know, because, for example, this group of adolescents, they are struggling. And in fact, you can see that their achievement goes down from time 1 to time 2 to time 3. But in the middle, one group, the experimental group, had an intervention around about here. And in that intervention, they were told about brain plasticity. They were told that they actually construct their own learning. And that encouraged them towards a more incremental theory of knowledge acquisition. And it improved their self-concept. And as you can see, it also gave them a better chance academically as a result, because they had learnt that their brains did not define who they were. They were actually constructing their brains. The decisions they made would influence their own brain structure, function, and connectivity. So that's in itself probably the most important message we need to get across to educators. If you want to know any more about this, there's my book. I get £1 for every one that you buy. So, you know, I'll be able to buy a pint of beer if 4 or 5 of you actually do purchase one. I hope you found that interesting. I know what you'd really like to know is a little bit about your... are there any questions about that? And then I'm going to move just a few do's and don'ts about your written essay, because I don't think I'm going to see you again before you start. I'm going to see you individually, but I'm not going to see you again as a big group. And I just wanted to do a few do's and don'ts about your essay writing. I'll probably be saying all this again when we meet in our smaller groups. But I thought I'd say it once to start with. Have we any questions about what we've just spoken about? Have I convinced you that neuroscience is relevant to education? Yes. Oh, great. Good. Okay, so here's a few things. Plan it, okay? Use a structure and subheadings that tell the story. If there are really good reviews on this subject already, look at their structure. 2,000 words is a really small essay, okay? Very few of you are going to be worried about filling it up. It's much more going to be the fact that you've got to be concise in what you say, and that requires work. So give yourself time to be able to edit it down, because it's going to, I'm sure you're going to produce something in the first instance that's going to be 3,000 or 4,000 words. You can introduce the topic and connect it to your own experience, but don't use more than 100 words on that, because that's not what I'm marking. It does help me to know that you know somebody who's dyslexic and this is their behaviours and they're very unhappy and you want to know more about it or something, or you work with children with autism. It does help me to know that, but I'm not actually giving you many marks for it, so keep it to 100 words. Use diagrams to indicate the location of the brain regions and explain processes. You should have already had some experience with that on the poster. Explain the meaning of the studies. Don't just say, oh, the anterior cingulate activated in this condition. Why? So what? What does that mean? What does it mean in terms of the cognitive function? What does the anterior cingulate do? How does that help us understand more about what you're interested in? I'm always going to be looking for those mind-brain links, not just talking about the brain, but what it means in terms of the mind, in terms of the cognitive function. Okay, I will, every year I end up writing this phrase a lot. What does that mean in terms of cognitive function? I have it, sort of cut and paste. Mention the limitations of studies. You're expected to do that at master's level, and you know that fMRI has bad temporal resolution sometimes. EEG has terrible physical, spatial resolution. PET, if you have too many of them, it's bad for you. but it has bad temporal and spatial resolution. But very good for messengers, so it's good at looking at specific functions. Summarize the main points at the end of the essay. It's a really good thing to do, because sometimes I write an essay and I think, I don't really know what this person is trying to tell me. But if you put a good summary at the end with bullet points, right? Not waffly, not prose, not paragraphs. I don't want paragraphs, just bang, 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 bang. Fantastic. Now I know something. Now I know what you were trying to tell me. And go back and check if it's there. But so can you, which helps you, develop it. I've said it before already, I'm going to say it many times. Link neural processes to cognition and to behavior. Why should these biological processes be important? Don't just tell me that the prefrontal cortex is implicated. Why would that be important? How could that be explained, or how can that be related to the behavior? I'm always looking for those brain-mind-behavior links. Brain-mind-behavior. Have you got all three in your essay? Something you should always be asking. And this is the sort of thing I get sometimes. In terms of declarative memory formation and using it was recently found that daytime training affects the characteristics of early night SWS with modifications reported in both stage 1 and the coherence of the NREM, low frequency, and blah, blah, blah. What do these measures have to do with declarative memory? I don't understand the link here. It just wasn't explained. Okay. I mean, I know, but I'm not testing my own knowledge. You have to make the link explicit. I know why that person was saying that. Link neural anatomy to cognition. What does that bit do? Okay. And I wrote a comment after this. How might problems with the hippocampus be related to autistic behaviors? What does the hippocampus do? How can this be used to explain autism? Technical processes and terms should be explained fully. I won't even read this out. Oh, sorry. I won't even read that out. But if you read that, it's like you get to the end of it, you go, oh. There's so many things. I still don't understand what some of these mean, actually. I don't know what an IL-1 beta and an IL-2 is. Even now, I've never come across that. I mean, maybe I should have done. I don't know what cholecystokinin is. I bet some people here who've got a neuroscience degree do, but I've got to admit I don't. Now, that's not a problem that I don't know it. The problem is that I'm thinking, do you know it? That's the problem. So you do need to explain these things. Proofread your work for sense. Okay, get a friend to read it. Because if they don't understand it, I may not. Recent studies, despite the decline older adults face during the course of aging, suggest that a variety of interventions can be used to minimize cognitive decline. What? I mean, I've put here if English is not your first language, but actually even if English is your first language, okay, I think this person, their English was their first language. I've already said provide conclusions and summary. They should distill key points, not make leaps into new territory. This isn't a time for you to start giving recommendations. It's not a time for you to start expanding onto the implications of what all this means. I just want to know what the key points are in your review. And it's certainly not a time to bring in new literature into the conclusions and the summary. Nothing you say in the conclusions and summary should not already have been explained once and more fully in the main body of the essay. A good summary. Actually, you need a good summary, a set of simple statements about what you think the takeaway messages are. And I've put often without references, but usually they're usually without references, actually. Okay, and I've actually written, this is a nice one, and I've written a nice comment, so I can write nice comments. Good final para summarizing your views derived from writing the essay. But I still had to criticize, didn't I? Though I would also mention need for further research. Okay, look at that for a quote. Whose work am I marking? I would just avoid quotes, okay? If you have to put one in, keep it really small. I am interested in your communication of the facts, not somebody else's. I'm not sure this person could possibly have passed. It's actually one quote after the next. I think maybe this person was writing notes and they just, I don't know what happened, but I can't mark that, right, because none of it is original work. So quotes are quite dangerous, and I would try to avoid them, really. Oh, I'll tell you something else as well. Plagiarism software, okay, it's a nightmare. If it's picked up, I have to do something about it. And some of the things that get picked up are really annoying, and they annoy me, and I don't really think they should be picked up. But help me out here, right? If you have a list of brain regions or a list of completely, you know, really uninspiring facts from a paper, but you've got to put them in a list, right? Rearrange the order, okay? Because I had 2 plagiarism cases a couple of years ago of people who had cut and pasted a list of brain regions that had been activated in a particular study. And because they didn't cut and paste them, because they did cut and paste them, it came up as plagiarism, which it is, technically speaking, plagiarism. But I find it really frustrating to have to take somebody, you know, to start taking action on somebody because if they just rearranged it, it wouldn't have come up, okay? And unfortunately, we're in unfortunately, we are in a social sciences faculty where the attitudes are slightly different, and there is a sense in which you should always put things in your own words. I don't know how to put a list of brain regions in my own words. It is really difficult, right? All I can think of is just to rearrange the order. But even at that level, do try to remember that it goes through this plagiarism software, and anything which looks like a sentence copied from, or half a sentence, or, you know, a quarter of a sentence copied from another essay, one of your old essays, maybe even from another university. We've had that as well, because it all goes into the same system. Or somebody else's essay or a book or something you found on the internet will be highlighted in red. Okay, and it's all totted up and you get figures for it at the end, or I'm sent figures for it. Yes?
What if right after the list you just cite it? Like, you know what I mean? Like, if I was like, I got this from Smith 2005. So I put the thing that was Smith 2005 right after it. Is that plagiarism? Because
it's not plagiarism, but that's a quote, isn't it?
well, you don't always, like, sometimes you cite things when you paraphrase it, just like at the end anyways. Because it wasn't your original. Like, if I got a fact from someone, like,
yeah, I mean, if it's not word for word, then it's not a quote. If it's if you've simply paraphrased it, it may not show your meaning. And I have marked essays where people have just simply paraphrased quite a lot. So you need to be a little bit careful of that as well, because it's very difficult to simply paraphrase and still show your understanding if you do it a lot. You know what I mean? So it does come through, because I can detect that as a marker, but actually it's not detected so much by the plagiarism software. Okay. Use diagrams to explain. If you mention field CA1, I'll think, well, where is field CA1? I think I need to know that you know where it is. Use primary sources. Don't say Weinstock measures Fujioka or Fujioka. I need to know you've gone to Fujioka and you've read it, okay, and that you're using it. Don't use secondary references, use primary ones. That's everything I really want to say. Have you got any questions? And we're going to be talking a little bit more about your essays when we meet as smaller groups, so don't panic. But I just thought I'd run through that while you're all together, because it might be helpful. Yes?
So how much do you have to highlight the theory behind the studies? Because most of the time it happens in studies we have a background.
That's a very, very broad question, a difficult one to answer. Oh, you mean in terms of that perspective? I don't need to hear you talking about neuroconstructivism at all, but I do need to hear you being non-deterministic in how you discuss the brain. And I do need to hear you being sensible about not thinking that a difference in cortical function is necessarily the cause of dyslexia. That in fact, systems can be more important, for example, underlying the cortex. No. I'm not so much interested in broad theories like neuroconstructivism. That was really just a tool to help you think. What I really want, if you're doing dyslexia, I need to hear your theory, the theory that you're examining in dyslexia. I need to see the neurocognitive evidence for it and an explanation of how that evidence informs our understanding of both the cognition and the behavior associated with dyslexia and the limitations, you know, why we shouldn't take it as a solid proof, you know. Not so much, no, not so much issues of broad paradigms, no. And can I also say that that referencing my work all the time does not get you extra marks, okay? I do get that sometimes. 2 or 3 students think, if I keep saying, Howard Jones here, Howard Jones there, Howard Jones there. No, don't do that, please. Yes?
A little bit of a technical question.
Yeah.
I don't think I've come across a good definition yet. If something's reporting increased mean diffusivity.
Oh dear, now you're testing me.
How would you describe that significance? I mean, I was trying to work it out, and I was starting to puzzle over whether it's an increase in passive activity or whether it's activated. I wasn't sure.
I think the important thing is, I mean, I think you need to explain that in your essay, what you mean by diffusivity.
If you're hearing it bandied around a lot and reported on wherever papers,
you need to go and find out what it means, and there will be people. There will be people. You know, there should be definitions of it available. There really should.
The thing is, it seems to mean something slightly different in all sorts of backgrounds, and it's not really explained.
If it's being used as a broad indicator of connectivity, which it sounds like it is,
yeah,
then that's appropriate.
That's all I think.
Say that, yeah. Any more questions? Any more questions? Can I just say what a lovely group of students you've been? I have really enjoyed this actually, and I've really enjoyed challenging myself with you, trying to explore some of these teaching strategies. Was that useful? Was that worthwhile? Should I do it again and persecute the students next year with them? Yeah. Okay, I will. Thank you for supporting me to do that. So hopefully you're going to be contacted and told what time you've got a meeting this time next week, or it will be the week after, and in your group. Okay. Secret Life of 5-Year-Olds is on Thursday evening. It is a fantastic episode. I've seen it 3 times myself, and I cry each time. Alfie also cries. The Alfie and Emily romance really takes off in episode 4. Okay. I'll see you soon then. The register is around somewhere. Don't forget this. Thank you. Well, thank you, wonderful students. Thank you. You've been great. Don't forget to sign the register though, because I need to know you're here.